we're going to continue with trig 1. The first part of trig 1 was you have to know your unit circle. You need to know how to break things between degrees and radians. And once you have that down, you're going to be taking a unit circle quiz on it until you get 100%. One thing we do need to touch on is how to, we talked about degrees to radians. We need to be able to go the other way. So make sure that if you're given a radian, such as, let's say, pi over 4. Now, again, you should already know that that's 45 degrees. But to prove it, you would say pi over 4, that's the radian, over pi, is how many degrees to 180? Well, the pi's cancel, so it's 1/4 degree to 180. So multiply by 180, and you get degree is 45 degrees. Now, you must put that little circle. That's how you denote a degree. If there is no little circle, it's implied to be radians. Sometimes radians would have pi's in them. Therefore, it is a radian. But if I have 45 degrees and I have 45, the only way I know them apart is by that little degree symbol. So this is degrees, this would be radians, or throw a pi in there would be radians. But you need to be able to go back and forth. All right, the next thing that we're going to be talking about are coterminal angles. Now, coterminal angles are angles, and you're going to see me use this abbreviation for angles just because I get tired of writing out the words. It's kind of a little less than with a half moon shape through it. That's going to be the shorthand for angles. Coterminals are angles in the same position. That means they have the same terminal and initial side. Terminal means end. So begin, initial, and end. They have the same beginning and ending. We are always going to find a least positive coterminal angle and the greatest negative coterminal angle. And the way we do this is if we're in degrees, we add and subtract 360. Or if we're in radians, we add and subtract 2 pi's. So let's think about why that is. Let's say I'm here at an angle. Here's my angle. By the way, an initial side is always the positive x-axis. Always. There's my angle. This is a theta. That's the Greek word for it. Theta is just a symbol for angle. We have many symbols for angles. It could be alpha, could be beta. Theta is just really common. And then we're going to call this our terminal side. And then we always have to have a direction. So right now, I don't know anything about this angle because there's 2 directions it could be. It could be a positive angle, or it could be a negative angle. I don't know which one it is. And I have to have these directional arrows in order to know that. Every time you make an angle, you need to make it with a initial side, an end side, a directional arrow, and a labeled angle. On just a generic axis is fine. So let's say I'm going to use this first one here, and I'm going to say 60 degrees is my angle. What is a coterminal? Well, the coterminal means that it has to be same beginning and same end. One has to be positive and one has to be negative. Well, the only way that I can get this 60 degrees to be the same, beginning, same end, same beginning, same end, is if I go around and around and around until I get to that angle. So if I'm going to go positively, I'd be going upwards. Well, that's already 60. That's what I started with. So that doesn't count. So I got to keep going and going and going and going and going until I get back to where I want to end. So what happens here is that I went 60, but that was my original. So I had to go all the way around in order to end back at that 60. Well, to go all the way around means I have to add 360. So 60 plus 360 makes this a 420 degree angle. Directional arrow, beginning, end, and a labeled angle. All right. Well, negatively means I have to start here. But negatively means I have to go downwards. And I'm going to go down until I get to my end. Well, there's my end. This is not a measurement of 60. This is the measurement of 60. So if this is a measurement of 60, and I went the other way, but I ended, I didn't go this 60, then I would subtract 360. So I have 60, I take away 360, and I get negative 300 degrees. Add and subtract 360. Now, if my problem would have been in radians, so instead of saying 60 degrees, this would have been pi over 3. That means I would have had to have changed this. I would write instead of 420 degrees, because I always have to keep it in the terms that I'm working in. My problem's in radians, my answer's going to be in radians. If my problem's in degrees, my answer's going to be in degrees. So first of all, if it's in 60 degrees, that would be pi over 3 radians. So how many radians is that? Well, if I were to go all the way around, that would be 6 pi over 3, because that's 2 pi. And another one. So 7 pi over 3. And if you're not sure, you're welcome to put 420 over 180. 420 divided by 180. And change it to a fraction. And there's your 7/3. Throw on your pi. Always in the numerator. There it goes. Now, negative 300 degrees. Well, negative 300 means I have a negative radian. Okay? And 300, negative 300, doesn't matter. If I know what 300 degree is, and I should know what 300 degrees is because it's 5 pi over 3. Therefore, if I went negative 300, I went negative 5 pi over 3. Keep your answer in the terms of the problem. So that's coterminal angles. The next thing we have is an arc length. All right, an angle of 1 radian, and we're going to call that theta, is a central angle of a circle whose intercepted arc, we're going to call that S, equals the radius, we're going to call that R, of a circle. So what that all says in formula is that the intercepted arc is equal to the radius theta. Pictorially, what we're talking about here is that here we have a circle, here we have a radius, here's the other radius. We're looking for that arc length. This is S. This is theta. There's my R. Because on a curve, it's not the same as a straight line. So it has a different formula. The length of the arc is different than the length of a straight line. All right, theta is always radians. So if you're given a problem and it says find the arc length, but the angle they give you is in degrees, you must change it. Otherwise, it's a very, very simple formula and equation to use. For example, it might say find the arc length if the radius is 3 and the angle is pi over 2. So the arc length is the radius times the angle, as long as the angle's in radians. Therefore, 3 pi over 2. And that's all you need. It really is meant to be that simple. You might be given the arc length is 5 and the radius is 2. What's the angle? Well, 5 is 2 theta, so theta must be 5/2. And there you go. Done. Don't make that too difficult. Last thing, revolution. A revolution is one time around. Now, those of you that are skateboarders or snowboarders, you do whatever, 2 revolutions, 5.5 revolutions, crazy kind of stuff that you all do. It's the exact same thing. So one time around means 360 degrees or 2 pi. If it's positive, you went counter clockwise. And if it's negative, you went clockwise. All right. So if you did 3 revolutions, what did you do in degrees? Well, 3 times 360, 1080 degrees. And if that was radians, you went 6 pi. So that's all it's looking for when it asks for revolutions. And that is the second part of trig 1.